Section 2.1 is about the division algorithm. Back in elementary school, you learned how to divide, and if you took a very simple problem like 79 divided by 6, you probably rewrote it as 79 inside this little box, a 6 on the outside, and you did it in pieces. So you said 6 went into 7 once, you multiply, subtract, and then you brought the 9 down. 6 goes into 19 3 times. That's 18. Subtract, and you bring it down. So you are left with a 13 up here, a 1 right here, and a 6 right here. Okay, your 79 is right there. All of these are part of the division algorithm. So what you have is 13 is your quotient. And it's been named that forever. 1 is your remainder. And what you had here was 79 divided by 6. So my A and B from the division algorithm are 79 and 6. The theorem says, the division algorithm says, given integers A and B, so you are given A and B, for us as 79 and as 6, with B greater than 0, then there exists a unique Q and R. In our case, the Q would be 13 and the R would be 1, satisfying A equals Q, B plus R. Our quotient times what we're dividing by plus the remainder. The theorem says that they exist and that they are unique, so the proof goes through both of those step by step. Now, what's important to note is that there are actually lots of ways to write 79. So if I say A equals 79 and I stick with this, it's my quotient of 13 times 6, because I was dividing by 6, plus a remainder of 1. 13 times 6 plus 1 is 79. That is the only combination in this form I'm going to get if I do 79 divided by 6. Right? Let's take a look at the number 12. If we say we've got 12 and I want to figure out what in the world do I get when I divide 12 by 2, okay, then I'm going to have a 2 here. Well, I know that 2 times 6 is 12 with a remainder of 0. So I could write 12 like this, 6 times 2 plus 0. I could also switch these two. All right. I could also say 12 equals 4 times 3 plus 0. Or 3 times 4 plus 0. Because 6, 2, 4, and 3 are all factors of 12, we've got remainders of 0. I can also write 12 as, let's say I'm going to divide 12 by 5. Well, it's 2 times 5, which is 10, but I still have a remainder of 2. So this is another way to write 12. I can write 12 in all kinds of manners, but when I'm given a specific thing to divide by, a specific number like 2 or 3 or 5, then I'm down to one unique Q and R. I was given 79 and 6, and that will give me 13 and 1 every single time. Now, on a side note, I just wanted to talk about this, the quotient and the remainder. Back in elementary school, you were probably told write down the 13 and then you wrote R equals or the remainder equals 1. A little later on, you might have said that this is 13 and 1/6. If you're learning to write it into your calculator, it was 13 and then you have to add on the 1/6, and your calculator should know order of operation, so it divides this before it adds the two together. It's interesting to note that we'll spend a lot of time in this class dealing with the remainder itself, and that's all you really care about. When you're working with modulo numbers, you're looking at remainders. So it's almost like going back to elementary school where you've got your R equals 1 and that's what you have and that's what you care about.